Okay, so in today's video, we are going to see what is wave and what's its classification. Alright, so before going towards the classification of the wave, we should know what's wave actually. Alright, so wave is a mechanism by which energy is transferred from one place to another without transporting the medium. Alright, for suppose we do have medium, that is water or air, either that is water or air. In that medium, in that air or in that water, there is one mechanism in which energy is transferred from one place to another, but that medium is not transporting itself. So that is basically a wave. So wave is a mechanism by which energy is transferred from one place to another, but without transporting the medium. Alright, so the second definition of wave we do have, that is, it is a traveling disturbance in any medium. So for suppose medium we do have, that is either water or air. So in that water or in that air, there is a traveling disturbance. So that traveling disturbance is what we call the wave. Alright, so the second definition of wave is what? It is a traveling disturbance in any medium. Alright, so now we are going to see what's the classification of wave. So let me write here wave types. Alright, so now let me make the arrows here. Alright, we do have two types of waves. We do have two types of wave. So the first type of wave is mechanical wave. That is what? That is a mechanical wave. And they do require medium. Like they require medium for the propagation. Wait, let me write that as well. They require what? They require medium. They require medium. While we do have another type of wave as well, that is electromagnetic wave. That is what? This is what? This is an electromagnetic wave. Alright? This is wave. I'm sorry. Wait, this is wave. And they do not require medium for the traveling. Alright? They don't require. Do not require medium for traveling. Alright? They do not require medium for the traveling. So now mechanical waves are subdivided in two types. They are further divided into two types. Now what those two types are, or what those two types are based on. So the first type is based on vibration of particles of medium. So let me write that as well. First type is based on what? It is based on vibration of particles of medium. So let me write that down. Wait. Alright. So it is, wait. Yes. So it is based on vibrating. I don't know what's happening here. Vibrating or vibration. Vibration is fine, I guess. So let me remove this. Alright. Vibration of particles of medium. Alright, of medium. So the first type is based on vibration of particles of medium. So this type is further divided into two types. Alright, this type is further divided into two types. So what these two types are, like based on vibration of particles of medium, how the particles of the medium would be traveling. All right, either they would be perpendicular to the direction of propagation, or they would be parallel to the direction of the propagation. So there are two types. The first one is what? It is the transverse wave. Wait, this is what? This is the transverse wave. Transverse this is the transverse wave. And transverse wave are what? Like there would be the particles moving from the, they would be moving perpendicular direction of propagation. So particles, wait, let me write this definition here so that it can be more clear to you. All right, so there would be a particles moving perpendicular to the direction of propagation, to the direction of propagation, direction of propagation, propagation. All right, so this transverse wave is what? Here the particles will be moving perpendicular to the direction of propagation. All right, so type which is based on the vibration of particles of medium 2, so that is longitudinal wave. All right, that is longitudinal wave. All right, so in longitudinal wave the particles would be moving parallel to the direction of propagation. They would be moving, wait, they would be moving how? Wait, let me use the color. This is written with dark pink, so I am writing with that. So there would be the moving of particles parallel to the direction of propagation, to the direction of propagation. All right, so here the particles will be moving parallel to the direction of propagation. In the transverse wave the particles were moving perpendicular to the direction of propagation. So here I am making the diagram of this longitudinal wave as well. So basically here would be particle moving parallel. All right, here would be compression, then rarefaction, then compression, then rarefaction. All right, so this is how the longitudinal waves are. These are what? Longitudinal waves. All right, so now the second type of wave which is based on what? That is based on energy transfer. All right, so here the mechanical wave has an other type as well. Wait, let me make that a little bit more far. All right, so this is based on what? This is based on the energy transfers. Based on energy transfers. It is based on energy transfers. Now further this is subdivided into two types. So what those two types are, let's see. So the first one is what? It is ascending, not ascending but standing wave. So this is what? This is standing wave. Alright, this is standing wave, and another type of wave which is based on energy transfers is known as progressive wave. It is progressive wave. Alright, so standing wave are what? Wait, let me make here the arrow first. So standing waves, then we'll be talking about progressive waves as well. So what are standing waves? Standing wave do not transfer energy. This is an important point. We will be discussing these all types of wave in very detail. Initially, I am just telling what these are. So they do not transfer energy. Alright. And the second type is what? It is a progressive, and progressive wave transfers the energy. They transfer the energy. Transfer energy. Alright, so this was all about the classification of the wave. In the next video, we'll be seeing that what these waves are actually. Alright, so this was all for today.